Hi guys, we're back again with another new topic for this week. We're going to be talking about prime factorization. Now, it's important that we understand the basics of what we're talking about here. In our title, we have the word prime. We need to know the difference between a prime number and a composite number. So let's think back just a little bit. In order to figure out factors of a number, those are those numbers that you can multiply together to create that number. We need to keep the idea of factors in our head because we're certainly going to be using them today. So factors are those numbers that you multiply together to make a number. And there are two different kinds of numbers. There are prime numbers and there are composite numbers. Let me give you an example of what those are. A prime number is a number that only has two factors, that number and 1. So if you have a number like 13 and I was trying to do a list of its factors, the only factors that I could come up with were 1 and 13 because that's the only way that you can make 13 is 1 times 13 or 13 times 1. That's what's called a prime number when it only has those two factors. Okay, the kind of opposite of that would be a composite number. A composite number is one that has lots of different factors. So say you had the number 12. There are lots of ways for me to multiply two factors together to get 12. The most obvious one is 1 times 12, right? So 1 and 12. I could also multiply 2 times 6. So 2 and 6 would be factors of 12. I could also do 3 times 4. So as you can see, a prime number only has two factors, that number and 1. A composite number has many more factors. There's not a certain number of them, but as long as it has more than 1 and itself, it's considered a composite number. Now, for today's lesson, we're talking about prime factorization. We are trying to get our numbers down to the prime numbers. Keeping that in mind, remember, prime numbers, 1 times itself. They've created what they call a factor tree to help with this, and it's a pretty good organizational tool to kind of help you. So I'm going to do a few of these with you so you can see what happens with this. And this will be directly from your book to start with, and then we'll practice a few numbers just to be sure. So example number 1 in your book has Mr. Dempsey surveying his class and finding that his students have a total of 36 pets. They want us to find the prime factorization of 36. And you'll probably remember doing this last year when I was working with the 5th graders, but here it goes. So we're going to take the number 36. That's going to be the very top of our tree. You've got numbered directions here of what to do. Number 1 says write the number to be factored at the top. So I'm going to do just like they have here in the book. Now what we're trying to do is to get this number into its prime factorization. So we're trying to use prime numbers as one of the factors that we multiply. My brain automatically thinks about, is this an even number or is this an odd number? It's always a good place to start. Well, I'm going to be looking at the digit at the very back of the number. Now if it ends in 0, 2, 4, 6, or 8, I know that it's an even number. And if it's an even number, it means 2 is one of its factors, right? It can be divided by 2. So I noticed this is a 6 right away. So like the book did, we're going to go ahead and do 2 times, well, how many 2's fit into 36? You may have to dig a little deeper here, guys. If you need to, come over on the side and do a division problem. I know it's been a while since we've done these, but we can do this. So my first step would be how many 2's fit into 3? Well, 1, 2. Then we multiply. 2 times 1 is 2. We're going to subtract. 3 minus 2 is 1. We're going to bring down our next number. Then we start again. How many 2's fit into 16? Well, that would be 8. Our guess goes up there at the top. Then we multiply. 8 times 2 is 16. And we subtract. So we can see, based on this problem, that 2 times 18 is 36. So we're going to put our 18 over here, and you guys actually have a box right there, like that, okay? Now, we're going to be looking at this next level and trying to decide what else we can do. Well, we've already created a prime number here. 2 is a prime number because the only way to make it with factors is 1 times 2. So we're going to leave that 2 alone, and it's going to keep dropping down with their tree, okay? So far so good, following right along. We're going to let this 2 just drop straight down because it's not changing. We know it's prime. We're going to have to break down this 18 into 2 more factor pairs. So let's see what we can do to make 18. Again, my brain is thinking, oh, it's an even number because it ends with an 8. So I'm going to take another 2 out. So I'm going to change colors right here, guys, so it makes it a little bit easier for you guys to see. So if I'm finding factors of 18, I'm going to try 2 again because I know it's an even number. How many 2's fit into 18? Well, 9 of them. So here we are at this step again. We've now got 2 prime numbers, and we've got a composite number here that we're going to have to work with. These 2's are going to stay the same because we have found what we need. Those are prime numbers, so we don't want to change those at all. So this guy's still in the box here according to that. And we're going to break down this 9 into 2 more boxes, just like we did. You guys are going to start to see the flow of this. See how this is coming down just a little bit each time? How can I make 9 with 2 factors? Well, we don't want to do 1 times 9 because we're not changing this number. We're trying to break it down into those primes. So it's not an even number. So I know that I can't do a 2. So I usually try the next factor up. Sometimes I'll try a 3. Well, just so happens that 9 can be made by 3 times 3. So if you will notice down here, we have all prime numbers. I want to show you one other way to do this, but I'm going to wait just a little bit so I don't confuse you. This part will help get you into what's happening right here. Now, what we have just created by breaking down this number into its prime factorization is this level right here at the bottom. They're all prime numbers, and when you multiply them together, we get the number that we started with, okay? You've got that set of numbers that goes right here. They also have another way to show you on the other side. So let's go ahead and fill in that chart to the right. So far this should be following right what you have on your paper. Let's do it again because there are different ways to do prime factorization. You don't always have to start with an even number. You could start with a different number. So they're showing you another way. So if you look to the chart on the right, we're still starting with 36. I'm going to do this one in black so it's easy to see. They started out by factoring out a 3. 3 times something is 36. Okay, if you're having a hard time thinking about it, if you're having a hard time counting those multiples of 3, it's totally okay to come over on the side and do the division problem. What is 36 divided by 3? Well, how many 3's fit into 3? 1. 3 times 1 is 3. Subtract. Bring down your next number. And we start again. How many 3's fit into 6? Well, 3 times 2 is 6. So I'm going to put a 2 up here. 3 times 2 is 6. And I'm going to subtract. When my remainder is 0, I know that I'm done. So I'm trying to find factors of 36. It is 3 times 12. So here we are right here. Now, we know that this 3 is a prime number because the only factors for it are 3 and 1. So we can leave this one alone. It's just going to drop down. Okay? Over here on the side, we need to break 12 down again because we know that that's not a prime number. There's more than one factor. We did it up here, right? So let's decide what we want to put in here. I think I'm going to do 2 times 6. All right? So remember, these drop-down boxes are just the factors that you multiply together to get the one on the top. Okay, so 3's already prime, 2 is now prime, but I need to break down 6 further. So I'm going to let these drop down again. I'm going to keep going until I get down to all prime numbers. So all I'm doing is just what your book has here. Well, we've got to break this one down into another set of factor pairs, right? How can I make 6? Now again, I don't want to put a 1 in there because that's not what I'm looking for. I have to start with my prime numbers that always start with 2's. Well, luckily, 6 is an even number. So I'm going to try and take out a 2 again. So 6 is 2 times 3. Now, if you'll notice, all 4 numbers on the bottom are prime numbers, and that means we're finished. Okay, so we should have both of our factor trees filled in now. At the bottom, they're asking us to look at what prime numbers we came up with. If you'll notice, these are the exact same 4 numbers, they just happen to be in a different order. And if you think about the commutative property, it doesn't matter in a multiplication problem the order of the factors because you're going to end up with the same answer. They just want to show us that there are two different ways to find this. Now, when you're doing the final step of this, they want these listed from smallest to largest. So you'll see down here it says the prime factorization of 36 is, and it's got 4 blanks there for you. Those blanks are going to be used for the prime numbers that we just came up with. These are the same set of numbers, they're just in a different order. We're going to start, doesn't matter which one we use because it's the same information. I'm going to use this one because it's right above it. We're going to start with the smallest numbers first. There's one of the 2's. Now we write the other 2, and then we can put our 3's in. All right, that's what's going to happen right here. Now, if we were to do this math again, we should end up with 36 if we did this correctly. So 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. We know that our answer is correct. And this little 4 blank here from your paper here is the same information on the bottom. They wanted us to check that, so it's good that we just did. When we did multiply those factors together, those prime factors together, we got 36. So we've now completed this part. Let's take a look at the back. There's another one that is done like this. Let's do another example together. The more you practice this, the easier it gets, okay? So let me back up over here, get rid of that one we just did, and let's do another one together. And then towards the end, I'm going to show you, I have a method that's very similar to this, but I think could be helpful to you. So I'll give you a second way of doing this, okay? This time, the number that they want us to find the prime factorization of is 24. So we're starting with 24. They already told us that they're going to start with a 3. So 3 times something. Well, let's use our minds. How many 3's fit into 24? That would be 8. Now, the 3 is fine because it's prime, so we're dropping it down to the next level. The 8 is not prime. There are more than one factor for 8. So we need to keep going until we get it down to those prime numbers. Now, again, I do the most obvious first, do the easy things first. This is an even number because it ends in an 8. That means I know that we're going to be able to take a 2 out of it. We can divide it by 2. How many 2's fit into 8? Well, that would be 4, right? If you count by 2's, 2, 4, 6, 8. Okay, our 3 is prime, our 2 is prime, our 4 is not. We got to keep going until we get down to a prime number. So let's drop these guys down again. 3, the 2, and we need to break down this 4 into 2 new factors. So what times what is 4? Well, it's an even number. Let's do some 2's. 2 times 2 is 4, right? Take a look at the numbers where we are now. These are all prime numbers. That means we have completed the prime factorization. You're going to write those in right here next to number 3. So they want to do it in order, so we want to make sure we do it the right way. So we always start with the smallest to largest. So 2 times 2 times 2 times 3. And these are just the prime numbers I'm getting from that bottom row, okay? Let's go ahead and do this math, which is going to be your answer right there to check it, to make sure we did this correctly. So 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. So we did check out there. Let's do one last problem together, and then I'm going to show you my technique, okay? So the next one down is find the prime factorization of 16. So it starts us off with a 2. They're really trying to help us out here. So how can I make 16 with 2 factors? 2 times what is 16? Well, think about your 2's. Count by 2's. Use your multiples. So 2 times 8 is 16. Okay, here we are. Going to take a look at this level again. The 2 is fine because it's prime, right? So we're just going to drop that down. But I can break 8 down into other factors, right? What can I multiply together to get 8? Well, again, I'm going back to that even number. I'm going to start with the 2. How many 2's fit into 8? 2, 4, 6, 8. 4 of them, right? Well, we're getting closer, but we're not finished. This 2 is done. This 2 is done because they're prime numbers, the 4 can be broken down again into 2 new factors. So what times what is 4? How about 2 times 2? And if you look across our bottom level, we have all prime numbers, so we know that we're finished. So let's go ahead and write down the prime factorization of this. This one's already in order because they're all the same number, but you still need to write it in. 2 times 2 times 2 times 2. And let's check that. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So our answer matches what we started with. That means we're doing it correctly. Okay, I want to show you another technique that I know how to do for this factor tree. You are welcome to use whichever technique works better for you. That's why we do lots of different strategies, because sometimes one works better for you than another. So this is how the book has it working on for this lesson, okay? This is another way to do it. This is the Miss G little tweak on it, okay? I'm gonna leave 16 up over here because I wanna show you my technique, and I'll do it in a different color so it's not confusing, okay? I'm gonna factor out 16, just like they did, but I'm gonna do it my way. So, I'm gonna start with 16. Same thing. I'm gonna say, how can I make 16? I would automatically go to that number. More than anything, this technique is just where the numbers are, okay? I'm still doing the same thing. 2 times 8 is 16. I know that 2 is prime. I'm gonna go ahead and circle it. This is how I help myself remember that I found my prime numbers. I'm gonna keep going with the 8. 8 is 2 times 4. Well, look at this. I just made another prime number. I need to break down the 4. That would be 2 times 2. Again, in my technique, this is the Mrs. G technique, not to be confused with what the book is teaching right now. This is another way. When I find prime numbers, I like to circle them. Helps me spot them when I'm writing down the prime factorization at the bottom, okay? Just like the original problem, I would then go through and follow this line. I would follow it right down the edge because I always do the smaller number first, so I could write down the prime factorization of this number. You'll notice I have the same 2's that you guys ended up with. It's just a different way of looking at it. Instead of dropping them down every time, I like to circle them. Okay? Let's do another set just to practice because I want you to see both ways, okay? So let's go ahead and take a look at another number, and we'll practice this both ways. You can use whichever one works best for you. For today's lesson, these boxes are designed for you to follow what the book is showing you. So it's okay to do it that way. Later on, if you're finding that the way that I'm showing you is easier, works better for you, you can definitely do that. Let's practice another set of numbers. Let's say 15. Okay, first off, let's do the book way. Let's do the way that they showed us. Okay, so we're gonna start with what 2 factors can we use to multiply to make 15? Well, my go-to is the even number, but that's not an even number. So I'm gonna try 3. 15 can be made by multiplying 3 times 5. Well, look at this. They're already done. Those are both prime numbers. I might not have picked the best number for this because guess what I'm gonna do? The same thing over here. 3 times 5, but I would have mine circled just because I like to circle my prime numbers. Let me choose a larger number and see if we can't get a little bit more information here. What if we have, let's say 26. Let's do it the way of the book first, okay? Because that's the new one we've been learning. We're gonna say 2 times, oh, I know a 2 because this is an even number. So again, totally okay to come over on the side. If you can't do it in your head, don't guess. Use the math to help you out. How many 2's fit into 2? 1. Subtract. Bring down the next number. How many 2's fit into 6? That would be 3. 3 times 2 is 6. So that would be 2 times 13. Well, look, I did it again. We've made prime numbers. There they are. If if I were to do it this way, my way, I would do 2 times 13 also, but mine would be circled. One last try. Give ourselves a little bit of room here. How about, let's do a bigger number. Let's do 42. Okay, let's do the book way first. So I would assume they would probably go with 2. Again, if you're not sure, do the division over on the side. Take 42 and divide it by 2, or count by 2s if that works better for you. How many 2's fit into 4? That would be 2 of them. 2 times 2 is 4. Subtract. Bring down your 2. How many 2's fit into 2? 1 of them. Subtract, and there you go. So it's 2 times 21. Okay? In the book version of events, they want us to bring down this 2, and just keep it as it is because it's prime, right? But now we need to break down 21 into 2 more factors. How can we make 21? Well, it's not divisible by 2 because it's not an even number, but let's try 3. How many 3's fit into 21? Well, we can count multiples, right? 3, 6, 9, 12, 15, 18, 21. That would be 3 times 7. So we are now finished with this because 2, 3, and 7 are all prime numbers. So for writing down the prime factorization, 2 times 3 times 7. I should try and do these a little bit differently for you. I have already been trained to do the smallest numbers first, so mine usually come out in order already. I'll try and do one for you that comes out of order a little bit, so we have to fix it at the end. Let's see. If I was going to do it the Mrs. G way, so again, you don't have to use it this way, but this is another way that I have learned how to do it. I would start here. What if we did 6 times 7 is 42? That works, right? Let me not put boxes here because I don't want to confuse you between the book way and my new way. So I would do 6 times 7. Well, 6 is not prime. I've got to keep breaking it down. So 6 would be 2 times 3. And 7 happens to be prime. So here we are. This is prime. This is prime. And this is prime. I'm at the end of all of my little tree limbs here. So this would be 2 times 3 times 7. All right. I think that's going to take care of things for today. If you need any assistance, you can always get a hold of me through Class Dojo or send email messages on my email, mvaw123@gmail.com.